Everyone, today we're going to be going over compound events, and so our objectives are to talk about how to find the probability of independent events, how to find the probability of dependent events, and then how to find the probability of disjoint and then overlapping events. So we've got a lot to do, so let's get started. We're going to begin with independent events. And we know that the word independent means kind of separate, and this is a different use of the word than when you talked about independent variables. So in probability, two or more events are independent if their outcomes have no effect on each other. So some examples that you might have heard of before if you've ever talked about probability would be picking a card from a deck and then flipping a coin. Those two events have nothing to do with each other. One event does not affect the other event. Another example would be picking two pairs of socks from a drawer with replacement. So if you're replacing the socks and then you're going and picking a second pair of socks, then that first event of picking the socks didn't affect the second event because you replaced the socks. Okay, here is the formula for how to find the probability of two independent events happening together. We want both of the events to occur, and so we're talking about an intersection of the two events, and the symbol for intersection is an upside down U, and the way that I like to think of this is the probability of A and B both occurring. So when you see the intersection symbol, you're thinking of the word and. So we want A and B to both happen. The probabilities are independent of each other, and so we simply multiply them together. Here's an example. Suppose that you roll a die 2 times. What's the probability of getting a 2 on your first roll and then getting a number greater than 3 on the second roll? So because this is a dice, we're not dealing with two events that affect each other. When we roll our second roll, it doesn't really matter what we got on our first roll. So let's find first the probability of rolling a 2. Okay, we know that there's only 1 2 on the dice and there's 6 numbers, so that would mean that the probability of rolling a 2 would be 1 over 6. The probability of rolling a number greater than 3, there are actually more options for this one. We want a number that's greater than 3, so we could either roll a 4, a 5, or a 6. So that's 3 ways of rolling a number greater than 3 out of 6 total possibilities on a dice. And if we want both of the events to happen, we want to first roll a 2, and then we want to roll a number that's greater than 3, then we would do 1 over 6 times 3 over 6. And you can choose if you'd like to simplify at the end or simplify ahead of time. And it's usually easiest to simplify ahead of time with probability so that your numbers don't get too large. So I'm going to do 3 divided by 3, which is 1, and 6 divided by 3, which is 2. And I end up with 1 times 1 over 2 times 6, which is 1 over 12. So the probability of having this scenario of first rolling a 2 and then rolling a number greater than 3 would be 1 over 12, or 1 out of 12. Okay, so here's another problem. I'll read it with you, and then I'd like you to pause the recording and try it out and write down an answer, and then check your answer once you're ready. So here's a problem. Suppose that you flip a coin, then draw a card from a deck. So 2 independent events here. So you flip your coin, then draw your card. What's the probability of flipping heads and then drawing a queen? So based on how we did the other problem, I'd like you to pause the recording and try this one out here. Okay, hopefully you found that the event of flipping heads was just 1 over 2 because we've got 1 head on a coin and 2 possibilities when we flip our coin. And then the event of drawing a queen, well, there's 52 cards in a deck, and there's 4 queens. So the probability of drawing a queen would be 4 out of 52. And if we want both of these things to happen, then we're dealing with 1/2 times 4 over 52. And if you simplify ahead of time, 4 divided by 2 is 2. Then you'll end up with 1 times 2, which is 2, over 1 times 52. And I could have simplified a little more than that ahead of time, but I'll go ahead and do it now. So if I divide them both by 2, I would get 1 out of 26. So that's the probability of both of these events happening. Okay, so that's it for independent events, and so go ahead and watch the rest of the playlist to learn some more about some other types of compound events you could have.